We are going through question 3, which says, during a telephone call, a phone uses a dual-tone frequency electrical signal to communicate with the telephone exchange. The strength of F of a simple dual-tone frequency signal is given by the function, this right here, where t is a measure of time and t is greater than or equal to 0. Part of the graph of y equals f of t is shown below. So if we come now and just come here, this is what it looks like. So before we look at any of the questions, the first thing I'm going to do is actually just get my CAS to define what this function is going to be. So I'm going to come over here to my CAS, I'm going to come here, and I'm going to say f of x. So even though they're using t, I'm just going to use x. Control equals sine, control divide, pi times x over 3, close my brackets, plus sine, open my brackets, control divide of pi times x over 6, close my brackets. And I'm also going to put in the fact that we know what the domain of this is going to be. So if we come over here for a second, you can see that my domain is where t is greater or equal to 0. So that means in my case, what I'm going to do is control this such that my x is this greater than or equal to 0, like that. I hit enter, I am done. Now what I can do is I can go control doc graphs, and I'm just going to graph what I've just done there. There it is right there. Now it doesn't look exactly like what we see here, does it? And the reason for that is just the window size of my CAS. So as you can see here, I'm going from 2 to -2, starting at 0 and going to 24. So I'm actually going to come here and go menu, window zoom, window settings, and my minimum X is 0. My max X that I can see on my graph is 24. My min Y is going to be -2, and my max Y is going to be 2. I hit OK, and now it looks exactly like we see on the exam paper, which is what I want. So it would have been fine the other way. I'm just pedantic. Okay, so now that we've got that, let us actually do the first question now. So we haven't even done the first question. The first thing it says is state the period of the function. State the period of the function. So to do that, what we're simply going to do is see where it repeats. So where does this thing repeat? So obviously, I'm starting here. Actually, let me get this one out. Oops, this one. So I'm starting here, and then I go up, down, up, down, up, and it looks like I'm starting again there, and it goes on all the way to 24. So it's quite clear that my period is 12. 12 is where it starts to repeat again. So what I'm going to do is I'm going to come down here, and I'm going to say that the period is equal to 12. And now we can come here and we can look at our examiner's report, and you can see that 76% of the state got this correct, 76. The answer is that. The question was answered well. Common incorrect answers were 6, 18, or 12 on T. So this was just a matter of looking at the graph and figuring out where it repeats. Let's keep on moving now to our next one, which is asking us the following. It's saying find the values of t where f of t is equal to 0 for the interval this. So what this question is asking us is simply where am I getting x-intercepts, or t-intercepts in this case, t-intercepts. So, and also you have to take a note of that as well. So let's come up here. Obviously, if it's between 0 and 6, 0 is going to be a point, 6 is going to be a point, and also 4 is going to be a point at which it is going to work. So I'm going to come down here, and I'm going to say t is going to be equal to 0, 4, and 6. If you wanted to kind of double check that we've done this correctly, you could do it a bit of a longer way. What we're doing here is we are solving for when my f of t is equal to 0, and I'm doing that for those t values, and I have put that in not correct. What went wrong there? It's giving me all the possible ones, so because this keeps on going to infinity, so I don't want that. So what I'm going to do, what a great teaching moment this is, control this, that, and I'm going to say between 0, control that, this, x, control that, this, 6, hit enter. Aha, 0, 4, and 6. So that's because I didn't restrict my domain here, so it just gave me to infinity. I didn't want that. I just want 0, 4, and 6. And there you go. Let's now look here, and let's see how people did with this question. So as you can see, let me get my highlighter out. 76% of the state got the full 1 mark. Those were our answers. The question was answered well. Some students only gave 2 values, either 0, 4, 4, or 6. So don't be one of those people. Make sure you see that you've got those inclusive brackets right there. I think those people who got that wrong didn't take note of that. Let's keep on moving. The next thing it says is find the maximum strength of the dual tone frequency signal correct to 2 decimal places. This is only worth 1 mark, so no working required. So what I'm going to do is simply come to my graph and say, well, what is this value going to be? I go menu, I go analyze graph, I go maximum from here to here. So it's just going to be what my y value is. So it's going to be 1.76. Now it says to 2 decimal places. I don't want to make a mistake here, a rounding mistake. So let's just go settings and let's just get this to go to a higher float just in case. Yep, so that's fine. It's going to be 1.76 as my answer. So let me come and get my pen. And I'm going to say that the max strength is 1.76. 2 decimals, way to go. All right, so let's now look at the examiner's report and see how people did with this question right here. Let me get my highlighter. 73% of the state got the full 1 mark. The maximum strength is 1.76. That's what we said here. Correct to 2 decimal places. The question was answered well. Common incorrect answers were this and this. Okay, I'm not quite sure why people have gotten that one wrong. That wasn't too tricky at all. Okay, let's keep on moving. Next, it says, find the area between the graph of f and the horizontal axis, and I'm doing that between t is 0 to 6. Okay, so let me show you. We need an exact value here. I can get the approximate pretty easily, so let me just show you how to do that. If I wanted the approximate, what I would simply do is go, well, let me first figure out where my 6 is. I know it's there, but let me just confirm that. Analyze graph 0. I know that from here to here, that is 6. So I'm finding the area bounded here and here. So if I wanted the approximate, now note, the question is not asking for the approximate, but if I did, I would simply go analyze graph, bounded area for this graph, my x-axis, from this point right here all the way to this point here. The approximate answer would be 4.7746, but it doesn't want the approximate, it wants the exact. So that means what we're going to have to do is go to our calculator page and do some integral work. So let's first write down what we're going to be doing here. This question is worth 2 marks, so I'm going to need some working. So let's come over here. And what I'm going to do is, let me get my pen, that would be helpful, wouldn't it? I'm going to say, I'm going to do the integral from 0 to, now what's that value right there? It is 4, but let's just make sure we don't make any mistakes there. Analyze graph is 0, so that x-intercept right there is 4. So I'm going to go from 4 to 0 of f of x, or let's make sure we use the right notation here, it's f of t, of dx. And now I need to do the same thing for this area right here. Notice that it's beneath my x-axis, so that means I'm going to subtract the integral of 6 to 4 f of t of dx. Ooh, another mistake. dt. Okay, and let's now find out what that is going to be equal to. So we're going to come to our CAS, and we're simply going to type that in. Quick way to get up the integral single, shift plus. Let's just come over here so I can see what we're actually doing here. Oh, there we go. So I'm going from 0 to 4. So this is where you got to be careful because I'm using x in my CAS, but the question on the exam paper is using t. So just be careful of that. Subtract from that, what is it going to be? Shift plus 4 to 6 of f of x of x. Okay, my answer is going to be 15 on pi. Too easy, 15 on pi. Let's now look at our examination report and see how the state did with this question right here. Let's bring this up. Let's get my highlighter out and have a look. So 62% of the state got the full 2 marks. This is what we wrote, so that is good. The most common incorrect answers were, so what did they do? They forgot about the signed area and the fact that when I'm beneath my x-axis, it's going to be negative. So to counteract that, I need to make it a negative there. So don't make that mistake. And then here, they didn't even take note of the fact that I'm dealing with some areas beneath it. They just went from one to another. So bad move there. Okay, let's keep on moving. Let's now look at this question right here. It says, let G be a function obtained by applying the transformation t to the function f, where this is t, and a, b, c, and d are real numbers. Now it's asking me to find the values of a, b, c, and d, given that this integral right here has the same area calculated in part d. Okay, so what we're going to do here is what I always like to do is we know that, actually, we don't have to do that. What I really have to do is just come look at my graph here, bring up this integral. So I'm really focusing here, didn't want to do that. Let's bring in my highlighter. I'm really focusing on this right here. And I'm asking myself, how can I make sure that I get the same bounded area, but now my restrictions are from 0, my boundaries are from 0 to 2, then 6 to 2. So the first thing that I would notice is that 0 to 2 looks awfully like 4 to 6. 0 to 2 looks awfully like 4 to 6 because the distance is 2. And then 6 to 2, well, that's a distance of 4. So it looks like this distance right here. So what I could do is I could simply reflect this in my y-axis. So what that would look like if I came here for a moment, and if I reflect it in my y-axis, that means I'm going to put a negative here, and that's going to shift it over here. Now I need to move it 6 units to the right. So I go tab, 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 up. I'm going to move it 6 units to the right. So that means, let's not mess this up. Let's put this in brackets. I'm going to -6 here. Have to put a bracket there. No, what? Perfect. All right, that's exactly what we wanted. Because now if I go menu, analyze graph, and I go 0, this right here is 2. So 0 to 2, 0 to 2, 6 to 2, 6 to 2. So that worked. That worked. So that means what my answer is going to be. Let's bring this up for a moment just so I can look at the what I did here. Whoops. Okay, so actually I am going to do what I initially said I was going to do. I'm going to write this out as being, this is x dash is equal to ax plus c, and this is going to be y dash is equal to by plus d. All right, so now let me just come here for a moment. If I am reflect in the y-axis, that means, therefore, that's going to affect, if I'm reflecting in the y-axis, it's going to affect my x values. So that means my a is going to be -1. So actually I have to write a, don't I? A is going to be equal to -1. I'm not doing any reflections in my across my x-axis. So that means my b is going to be equal to 1. I also know that I am not doing anything I'm not doing any vertical translations. So d is going to be equal to 0. And for my c, I shifted it 2 units to the right. So that means it's going to be +6. And that should work. So don't get confused with what I'm, like here I have to put -6 to move it that way, but when it's in this form, it's going to be +6 to get it to move to the right. The next thing I need to take note of is the fact that I could move this by a period to the right, so -12, and I'm going to still get the same bounded area. And I could do that again, so tab. I could go 24. Whoa, that's not 24, 24. And it's still going to get me the right answer. So that means I could actually plus 12n to this, and I have to tell them what n is, n is going to be an element of integers that are positive, and it's also going to include 0 because I can do it without it. Okay, whew. I think that's it for that one right there. I might get rid of this because I don't really need it. I just want to make my working as neat as possible. So let me just put this right in the middle, like so. And I can say here what I'm actually doing. So let me actually write down what I did so we are all on the same page. I reflect in y-axis, and then I translate in the positive x direction. Positive x direction by 6 units. Or 6 plus 12n, where n is an element of all my positive integers, including 0. So that is just kind of spelling out what I did. So the examiners should have no reason for marking me wrong. Okay, let's now look at the examiner's report and see what they wrote. So let's bring this up and let's just make this as big as possible because we're going to spend some time on this one right here. All right, let's get my highlighter out and have a little bit of a look. So as you can see, reflect in the y-axis, that's what we did. We reflect in the y-axis and translate 6 units left. Okay, so I'm going to be honest, I'm confused by that. Now, I'm never going to say that VCAA is wrong. VCAA is always right. They are immortals. But you're not translating to the left. You're translating in the positive x direction, which is right, isn't it? And then the thing is, like, we've got the same thing. We say a is equal to -1. They say a is equal to -1. We say b is equal to 1. They say b is equal to 1. They say d is equal to 0. They say d is equal to 0. Okay, but here's the thing. They say move 6 units to the left, and then they put 6 plus 12n. Well, if this is positive 6, it's going to the right, isn't it? So it's this. So ask your teacher about this. Don't take my word from it, just a crazy person on the internet. Ask your teacher about that. I'm not sure why they've put left there. I've even checked the math solutions, and they too say left. So I'm looking at them right now. Move 6 units to the left, and they're saying it's 6. So I must be missing something there. This must be my bad. So I'm in no way affiliated with VCAA. So you need to double check that. Ask your teacher what is going on there. Why are they saying left, but then 6 here? But then the rest is correct. The rest of what we wrote, they have written right there. So I'm not, yeah. Let's keep reading here. It says, this question was not answered well. Only 10% of the state got the full 2 marks. Some students attempted to describe the transformations, but gave incorrect or no values for A, B, C, and D. Okay. So I'm not sure why they're saying left there. That's going to haunt me. And this is just an alternative way to do it, in which you first reflect in the x-axis, and then you translate the other way. Okay, let's keep on moving. Actually, do you want me to show you how to do this other way? I might as well. We're here, so we might as well do it. So if you were to do it the other way, what would happen is we're going to go tab. We've got another one here. So this time, what I'm going to do is I'm going to reflect it in my x-axis, right? So I put that negative out the front. And if I do that, I wind up with this. And now what I'm going to have to do is I'm going to have to shift it to the left by 6 units. So if I shift it to the left by 6 units, let's go tab again. Let's come back to this one right here. And let me just untick this one for a time being. Oh, look, that stays. That's amazing. If I shift it to the left, that means I'm going to plus 6 here, which is going to bring it there. And as you can see, that time it's going to work. So it's the same area right there. So what I've done there is, if we just bring tab up for a moment, because I've shifted it in my x-axis, That means I've changed all my y values. So that means this time my a is going to be equal to 1 and my b is going to be -1. And also my c is going to be, if we look at our graph here, we're shifting it to the left this time. So that means it's going to be -6. It's going to be -6. And then we have to remember that we can move it by a period. So I'm going to plus 12n, and I'm going to define n as being all my real integers that are negative. So that means when I put a negative number into this, it's going to make this -12. So I'm moving it to the left by a period. And I'm also going to say that this is the union of 0, because I can include a 0 there. And that is what they have written here. So, sorry, let me come here. Let me put this down the bottom so we can look at it all at the same time. And let me just write down that this is an alternative way. Alternative. And in this alternative way, we are reflect in x, then we are translating in the negative x direction. Whoa, I can't spell direction. Okay, so as you can see here, because we're reflecting in the x, we're making the y -1, so the b, so that's in front of the y, and then we've got -6x plus 12n, and that is what they have here, and they have defined my z as, you got that negative right there, including u. Oh, and you also have to say that we're not doing any vertical translations, so my d is going to be equal to 0. Now, once again, I must be missing something here. They are saying, if I get my red out for a moment, they are saying that you're moving it 6 units to the right, but I'm saying translate in the negative x direction, which would be the left. So I'm just confused by this left and right here. I'm guessing I'm just missing something there. This is my bad. I apologize. I'm missing something there about what they're doing. Okay, let's keep on moving. Last question. The rectangle bounded by y is equal to k, where k is all real positive numbers, the horizontal axis. So the rectangle bounded by the line y equals k, the horizontal axis, and the lines x equals 0 and x equals 12 has the same area as the area bounded. Let me start again. I'm fried. The rectangle bounded by the line y equals k, the horizontal axis, and the lines x equals 0 and x equals 12 has the same area as the area between the graph of f and the horizontal axis for one period of the dual tone frequency signal. Find the values of k. So let's come up here for a moment and look at our graph and see what's going on. So let's look at our graph. So what they're saying is that I have y equals k, so let me just draw that in. I have y equals k, and that is bounded by x equals 0. Oh, I could not have put that in the worst spot. X equals 12. So this area right here is going to be the same, and because it's also bounded by the x-axis, that area is going to be the same as the area bounded by the graph and the x-axis for one period. So this, that right there, they're going to be the same. Now we know that the area of this section and this section is going to be 15 on pi. That's what we found in a previous part. So now if I want to add on to that these two sections, I'm simply going to double it. So I'm going to times that by 2. So it's going to be 30 over pi. Knowing that, I can say, well, let me now talk about this rectangle for a moment. The area of this rectangle, it's going to have a width of 12 and a height of k. So that means it's going to be 12k for the area of it. If I know that my area is 30 on pi, then I can easily find out what k is going to be. So there's a lot of working there. So just so we have that all in the same spot, I might just copy this and bring it down. Control C. Let me just bring this down here for a moment so we can see it in all its glory. So we've got that right there, just so you can see what's going on. Now, what we're going to do here is I'm going to say that the area of f, the horizontal axis, and 1 period, that's simply going to be 15 pi. Sorry, what was it again? It was 15 on pi. 15 on pi times 2 is going to be 30 on pi. And then to find the value of k, I'm going to say it's 30 on pi is equal to 12k. Therefore, k is going to be equal to, and I'm actually going to do this on my CAS because I don't want to make a mistake. So, although this is pretty easy algebraic stuff, we're going to solve brackets 30 on pi when that is equal to 12k, and I'm solving it for k. My answer is going to be 5 on 2 pi. So if you've got the CAS, why not use it? It's going to be 5 on 2 pi, and that is going to be my answer. It never hurts to put in more information here. So you also might want to put in area of rectangle is going to be equal to 12 times k. That's kind of, that information's already kind of there, but I think that would be enough. All right, let's come and look here for a moment. So according to the examiner's report, 36% of the state got the full 2 marks here. Our answer is this, k is equal to that, so we got that. And what we did was this. We went 2 times this, we set it equal to 12k, so that seems like a legitimate way to go about it. You could go about it a bit of a longer way, in which here, what you're doing is you are finding the area between those graphs for 1 period, it looks like. And then you're timesing it by 2, so it's just that bit. So many students did not double their answer from question 3D, and that's what we're doing here. That's why we're timesing it by 2. We're just doubling our answer from question 3D. Then we're setting that equal to the area of the rectangle and solving for k. So with that being said, hopefully that was helpful and you understand how to go about these questions. A nice little question there, question 3 of exam 2 of the 2019 Maths Methods exam. Hopefully you found this helpful, and I'll see you in the next video.